Deep in the California desert, America's newest fighter is taking shape. This is the story of the F-47. 6 years in development, the F-47 program is the most ambitious leap in air superiority since the F-22 Raptor. With a projected cost of $89 billion, this sixth-generation fighter is being built under unprecedented time pressure. Originally scheduled for 2032, the timeline has been compressed by 4 years to 2028. The reason: near-peer adversaries are developing capabilities that threaten American air dominance for the first time in decades. China's J-35 and Russia's Su-75 programs are advancing faster than predicted, forcing the Pentagon to respond. The F-47 isn't an incremental upgrade. It represents a fundamental reimagining of fighter aircraft. At its heart is the AN/APG-95 radar, capable of tracking 200 targets simultaneously at ranges exceeding 300 miles. The pilot uses a neural responsive interface, reducing reaction time from thought to action to under 200 milliseconds. Every system was tested in 18,000 simulated flight hours before the first prototype left the ground. Powering the F-47 are two adaptive cycle engines, each producing 45,000 pounds of thrust with variable bypass ratios. These engines switch between combat and cruise modes in under 3 seconds, extending range to 2,400 miles. The stealth coating uses metamaterials that absorb radar waves across multiple frequency bands, making detection nearly impossible. Its radar cross-section measures 0.0001 square meters, the size of a marble on enemy screens. The internal bays carry 6 AIM-260 long-range missiles and 2 AIM-9X sidewinders, maintaining stealth while armed. The AIM-260, built for the F-47, engages targets at 200 miles with a 65-pound high-explosive warhead. Upon impact, the warhead creates a fragmentation pattern, destroying aircraft within a 40-foot radius. The F-47's sensor fusion combines radar, infrared, and data link inputs into one comprehensive battlefield picture. 6 infrared cameras provide spherical awareness, detecting missile launches up to 800 miles away. The pilot's helmet projects threat data directly onto the visor, eliminating the need for cockpit instruments. The secure data link shares targeting data with 30 friendly aircraft while remaining undetectable to enemy intelligence. This networked approach transforms the F-47 into a node in a vast combat network, multiplying effectiveness. Managing heat from powerful electronics requires a liquid cooling system dissipating 150 kilowatts continuously. The aircraft generates 1 megawatt of electrical power, supporting directed energy weapons for future upgrades. By 2030, the F-47 will carry a 300 kilowatt laser weapon to destroy incoming missiles at the speed of light. In September 2024, the first F-47 prototype completed high-speed taxi tests, reaching 180 miles per hour. 3 months later, test pilot Colonel Sarah Martinez took the F-47 into the sky for the first time. The 47-minute flight validated basic handling at 15,000 feet and a speed of 450 knots. Flight testing has expanded to envelope expansion, demonstrating sustained 9G turns and 60-degree angles of attack. Test pilots report handling superior to the F-22, with AI making extreme maneuvers accessible and safe. Onboard AI processes 400 terabytes of sensor data per hour, filtering noise for the pilot. This power comes from 7 mission computers working in parallel, operating at liquid nitrogen temperatures. With aerial refueling, the operational radius extends to 1,800 miles for strikes deep into contested airspace. From Guam, F-47S can reach any point in the South China Sea, providing a rapid response capability. Production is now 4 aircraft per month, with plans to double that by late 2026. Congress authorized 200 aircraft through 2035, with each F-47 costing roughly $285 million. The $89 billion total covers research, production, and 30 years of maintenance. Designed for a maintenance cycle of 12 hours per flight hour, the F-47 reduces operational costs by 40%. AI monitors structural health in real time, predicting component failures and scheduling maintenance automatically. The electronic warfare suite can identify and jam 500 enemy systems across the electromagnetic spectrum. The AN/ALQ 300 system creates dozens of false radar signatures, making one Ishi F-47 appear as an entire squadron. This renders enemy air defenses blind, opening corridors for follow-on strikes. In combat, the pilot sees threat rings in friendly positions overlaid on the real world through the visor. The operational ceiling exceeds 65,000 feet, engaging targets at altitudes enemy fighters cannot reach. Maximum speed is validated at Mach 2.4, with supercruise capability at Mach 1.7 without afterburners. Advanced efficiency gives the F-47 35% greater range than the F-22 while carrying more sensors. Pilot training has begun, with 40 Air Force and Navy pilots qualifying in advanced simulators. The first operational squadron, the first fighter wing at Langley, will receive aircraft in early 2028, and infrastructure investments exceed $2.3 billion for hangars and specialized training facilities. A naval variant, the F-47N, is under development with reinforced gear and folding wings for carriers. Carrier trials are scheduled for 2027, with the Navy equipping 4 carrier air wings by 2030. The airframe withstands catapult stresses of 4.5 Gs while maintaining critical stealth characteristics. Strategic plans position squadrons in Japan, Poland, and Qatar, creating overlapping zones of air dominance. In war games, F-47s successfully penetrated advanced air defenses without detection. Simulated trials show F-47s achieving kill ratios exceeding 20-1 against fifth-generation aircraft. A typical strike involves supersonic ingress at 50,000 feet, weapon release, and high-speed egress. For maximum payload, external hardpoints carry 18,000 pounds of weapons, though this reduces stealth. Commanders balance stealth with firepower, choosing between penetration or maximum destruction. New manufacturing techniques reduce production time by 40% using 3D printed titanium. Every aircraft undergoes laser scanning to guarantee consistent stealth performance across the fleet. Protecting the software from cyber attacks requires 200 specialists monitoring systems 24 hours a day. The 40 million lines of code are protected by quantum-resistant encryption against future threats. The F-47 receives over-the-air software updates every 60 days, improving capabilities without physical changes. Virtual reality allows pilots to experience 500 combat scenarios before flying the actual aircraft. Turnaround time is reduced to 34 minutes, allowing 4 sorties per day during high-intensity operations. The Air Force has procured 1,200 AIM-260 missiles, stockpiling weapons for the coming fleet. Weapons separation tests validated all missiles at Mach 2.2 and altitudes exceeding 60,000 feet. Test firings achieved a 94% hit probability against maneuvering targets, a new record. Environmental testing validates operations from -65 degrees in the Arctic to 125 degrees in the desert. The airframe survived direct lightning strikes of 200,000 amperes, with all systems operating normally. 5 allied nations have expressed interest, with Australia and Japan leading negotiations. Export versions will feature modified sensors to protect classified tech while maintaining high effectiveness. The design includes provisions for hypersonic missiles, an autonomous drone control plan for the 2030s. By 2032, each F-47 will command 4 autonomous combat drones, extending its reach exponentially. Integration of hypersonic weapons like the AGM-183 allows the F-47 to strike targets 1,000 miles away in minutes. Its multi-role capability means one squadron can perform air superiority, strike, and electronic attack. Despite the timeline, the program remains on schedule and within budget. This capability arrives as the strategic balance in the Pacific faces unprecedented challenges. The F-47 represents America's commitment to air superiority for decades. The future is being built today,